Every data set tells story, but uncovering that story from thousands of rows and columns is not always easy. When you first open dataset, it can feel overwhelming because of endless numbers, unfamiliar patterns, and no clear direction. But before we build models, before we run correlation, before we predict anything, we must begin with one foundational step: descriptive statistics. Descriptive statistics form backbone of every analytical workflow. Whether you are analyzing sales performance, customer behavior, academic results, or scientific measurements, these tools help you summarize large data sets, highlight key patterns, and convert raw information into meaningful insights. Welcome back to Shital's Data Desk, your one stop destination for clear, practical, and professionally explained data concepts. In today's video, we are taking structured, in-depth journey through most essential components of descriptive statistics. We will explore measures of central tendency, understanding your data's typical values, measures of variability, revealing how spread out your data truly is, distribution shape, identifying skewness, symmetry, and patterns, outliers, detecting values that can distort your interpretation, visualization, using charts that bring descriptive statistics to life, real world dataset example, common mistakes analysts should avoid, complete summary to tie everything together. By the end of this video, you will be able to confidently explore any dataset, extract key insights, and prepare your analysis for more advanced statistical techniques. So, let's get started with what is descriptive statistics. Descriptive statistics help us summarize, simplify, and explore data. Think of it as creating a clear, organized introduction to your dataset. Instead of presenting thousands of raw values, descriptive statistics help you communicate, such as what is typical value, how much does data vary, are there unusual values, what does distribution look like, what initial patterns can we observe. In other words, descriptive statistics convert raw data into meaningful, easy to interpret snapshot. These methods are built around three essential components. First, measures of central tendency. It describes center or typical value of data. Second, measures of variation. It shows how spread out or consistent values are. Third, distribution shape. It explains how data is arranged, symmetric, skewed, clustered, or dispersed. Now, let's explore each of these pillars in detail. Let's begin with measures of central tendency, statistical tools that describe where data tends to cluster. Three most common measures are mean, median, and mode. Each provides different perspective on typical values. First, mean. Mean is calculated by summing all observations and dividing by total count. It incorporates every data point, which makes it useful but also sensitive to outliers. Example: let's consider data set of 240, 260, 270, 280, 275, 290, 450. Unusually high value of 450 pulls average upward, demonstrating how outliers can distort mean. Second, median. Median is middle value after sorting data. For odd number of observation, it is central item. For even number, it is average of two middle values. Because it is unaffected by extreme values, median provides more reliable typical value when data is skewed. Third, mode. Mode represents most frequently occurring value in dataset. It is particularly useful for categorical data, such as product types, colors, or sizes, and for identifying common patterns. Numeric datasets may have multiple modes or none at all. Now, let's see when to use each. Mean. When data is roughly symmetric and you want to use all available information. Median. For skewed distributions or data containing outliers. Mode. For categorical variables or when identifying common outcomes. Analysts often report both mean and median to present more comprehensive view of data. Now, let's move on to second measure. Measures of spread. While central tendency tells us where data is centered, measures of variability tells us how much data fluctuates. Two data sets can share same mean but vary dramatically in their spread, and spread often reveals more than average itself. Common measures of spread are range, interquartile range, variance, and standard deviation. Let's start with first range. It is simplest measure, difference between maximum and minimum value. Quick to compute but extremely sensitive to outliers. Example: if we use same data set, Then 210 is range. Second, interquartile range. In short, IQR. IQR measures spread of middle 50% of data. Difference between 75th percentile, that is Q3, and 25th percentile, that is Q1. Because it focuses on central values, IQR is highly resistant to outliers. It is commonly visualized using box plot, which also helps identify potential outliers. Third, variance. Variance quantifies how far observations deviate from mean, expressed in squared units. High variance indicates considerable spread. Low variance suggests data is consistent. Fourth, standard deviation. Standard deviation is simply square root of variance, bringing measures back to original units of data. Standard deviation is widely used in analytics, modeling, and forecasting because it gives clear sense of how tightly data clusters around mean. Example, two employees work average 8 hours per day. One varies between 7.9 and 8.1 hours, and other fluctuates between 5 and 11 hours. Their mean match, but their consistency does not. Here, spread tells real story. Third measure is shape of data. Not all data follows perfect bell curve. Understanding shape of distribution helps you choose appropriate statistical methods and interpret results accurately. Two main shapes are skewness and kurtosis. First, skewness. Skewness indicates whether distribution leans left or right. Right skewed means long tail to right. Example, income, sales. Left skewed means long tail to left. Example, high scoring test where most values cluster near top. Rule of thumb, median is greater than mean indicates left skew. Mean is greater than median indicates right skew. Skewness helps determine which measures of central tendency is most representative. Second, kurtosis. Kurtosis describes whether distribution is sharply peaked or more flattened. High kurtosis means heavy tails, more outliers. Low kurtosis means flatter distribution, fewer extremes. These shape characteristics are essential when selecting statistical tests and modeling techniques. Now we understand center, spread, and shape. But every dataset has its rebels, unusual values that can either distort your analysis or reveal something important. Let's talk about outliers. Outliers are not simply errors, they are signals. They may indicate data entry mistakes, rare or unusual events, unique customer behavior, business opportunities. We can identify outliers in few different ways, and each one reveals something little different about your data. First, box plot rule. If value falls beyond 1.5 times IQR, box plot will automatically flag it as potential outlier. Simple, visual, and very commonly used. Second, Z-score method. If data point is more than 3 standard deviation away from mean, it is statistically unusual and likely an outlier. And third, basic visualization. Sometimes just looking at scatter plot is enough. Single point sitting far away from main cluster immediately stands out. But here is the most important reminder. Outliers should never be removed just because they look strange. Before deleting anything, always stop and ask, is this mistake or is it meaningful? Because sometimes that one odd value is not noise, it is insight your analysis was waiting for. Descriptive statistics become far more insightful when paired with right visualizations. Chart translate numeric patterns into something we can immediately interpret. Here are most essential visual tools. First, histogram. Histograms reveal overall distribution, shapes, skewness, and where data tends to peak or spread. Second, box plot. Box plots summarize median, quartile, spread, and potential outliers all in one view, making them ideal for quick comparisons. Third, scatter plot. Scatter plots help identify relationships, clusters, and anomalies between two numerical variables. Fourth, bar chart. Bar charts are perfect for categorical data, frequencies, segments, customer groups, product types, and more. Fifth, density plot. Density plot smooths histogram into clean curve, making it great for presentations and visual storytelling. Sixth, violin plot. Violin plots combine distribution and density in one graphic. They are especially useful when comparing groups or categories. Visualizations transform insights into understanding. Numbers speak, but charts make their messages impossible to overlook. Now, let's apply these concepts to real dataset. Imagine we have 12 months of retail store sales data. Here's what descriptive statistics tell us about this data. Mean 17208.33. Median 15750. Mode none. Interquartile range 5750. Standard deviation 7820.76. Shape right skewed because of extreme 40,000 value. And what insights we got? Most months fall between 12,000 and 18,000. One month stands out as unusually high, likely represents festival or promotional spike. Overall trends show steady growth over year. With just descriptive statistics, we already understand business story, seasonality, performance consistency, and potential opportunities. Even experienced analysts sometimes misinterpret descriptive statistics. Here are most frequent mistakes to watch out for. First, using mean for heavily skewed data. Second, ignoring outliers rather than investigating them. Third, misreading histogram shapes. Fourth, assuming range reflects two spread. Fifth, using standard deviation without checking distribution. Sixth, interpreting charts without context. 7. Forgetting to connect insight back to business question. Remember, descriptive statistics is not just about calculation, it is about interpretation and meaningful decision making. Let's summarize what we learned today. Measures of center, mean, median, mode. Measures of spread, range, IQR, variance, standard deviation. Distribution shape, skewness, and kurtosis. How to identify and interpret outliers. Key visualizations, histograms, box plots, scatter plots, and bar charts. Complete walkthrough with real dataset. Common mistakes analysts must avoid. Descriptive statistics is powerful. It turns confusion into clarity and numbers into insights. In our next video, we will take this further to inferential statistics, testing ideas with data, where you will learn sampling, confidence interval, p-values, and hypothesis testing in depth. If you found this video helpful, don't forget to like, share, and subscribe to Sheetal's Data Desk for more clear and practical data insights. Thanks for watching.